One of the first topics we have for Integrated 2 is on geometric figures. So this is understanding what the relationships are within a figure, ideas of symmetry, what parts are congruent, and then combining some of these ideas when we put them in with Venn diagrams. So the first thing that you're going to need to be able to do is just be able to label the shapes correctly. So for this first one we see right over here, the right triangle, you have to realize that, of course, it's a triangle with three sides, but to make it a right triangle, we need to identify a right angle. The best way of doing that is by putting a little square in that corner, which is equal to 90 degrees. For an isosceles triangle, the definition of an isosceles triangle is a triangle that has two equal sides, or two sides that are congruent. So we're going to mark those sides. And another feature that also comes off of it is the angles opposite those two sides end up being congruent. So these two angles would also be equal or congruent. Now, what happens with the triangles, if you look at this triangle and I take it and I fold it in half right down through the center, it's going to lie on top of itself. This is what's called reflective symmetry. So this has reflective symmetry. It does not have rotation symmetry. Rotation symmetry means you can rotate it less than 360 and have it lie on top of itself. Equilateral triangle, all the sides are equal, and because of this, all the angles are equal. So technically, when you look at all the angles being equal, we say that's equiangular, and we have all the sides equal, we say that's equilateral. But with our triangle right here, with our equilateral triangle, all the sides are congruent, all the angles are congruent. This has both reflective and rotational symmetry. Now you may also see the ideas combined, doing an isosceles right triangle. So we have a right triangle, and we have two equal sides. Now, also it's going to be true, which is not going to be quite as important, but these angles also are going to be congruent. So if you get at least this part, it will help you to get through most of the different parts, be able to label up appropriately based on what the definition is. But knowing that the angles opposite the two sides are equal in a triangle are going to be congruent makes it a lot easier to do a lot of different problems. Plus, this one also has reflective symmetry. If I folded it across that line, it will lie on top of itself. Okay, quadrilaterals. So we have a variety of different quadrilaterals. A parallelogram, definition of a parallelogram, it has two pairs of parallel sides. So this side's parallel and these sides are parallel. Now there's a lot more to the figure than just the parallel sides. The opposite sides are congruent, so I'm going to mark those. The opposite angles are congruent. So these two angles and then these two. Notice that when we marked the different angles, the ones that are opposite here, these two, are not marked the same as the ones over here. They're different angles. They have different angle measures. In fact, these two angles will add up to 180. That's because the parallel lines end up being same side interior. But make sure that if you have different angles that are not congruent to each other, you label them differently. Some students like to do the tick marks. So you can do an arc and then do a single tick mark like this, and do another arc and then put a couple tick marks into it, just to distinguish which ones are which. For a rectangle, definition of rectangle, it has 4 right angles. But it's still a parallelogram. So these sides right here, when we would do parallels, we do it with little arrows. Those two sides are parallel. These sides are parallel. Also, the opposite sides are still congruent. So this side is congruent to that side, and that side is congruent to that side. Now for a square, well, all this angles, it's basically a rectangle where all the sides are congruent. So it's still going to be a parallelogram too. So this side and this side, and then these ones. Doesn't matter which way you have the arrows go, as long as you can match them up. For a rhombus, the definition of a rhombus is a quadrilateral with 4 equal sides. So a rhombus is similar to a square, but a rhombus does not have right angles. It does have, it's still a parallelogram, so that again, this side is parallel to this one. These two sides are parallel. Also has that this angle equals this angle, and these two angles are equal. Okay, for a trapezoid, basic definition of a trapezoid has one pair of parallel sides. That's these. Now, when you get to special features of trapezoids, such as an isosceles trapezoid, you have the parallel sides, but you also have the sides that are equal. And it comes out that the two base angles, these angles and these angles, are congruent. We call those the base angles. Now for a right trapezoid, well, we have a trapezoid, so we have the two parallel sides, and we have right angles. For a kite has two pair of adjacent sides are congruent. So that pair and then this pair. Now it's also true that we have a couple angles that are congruent. Those two. Not the top one and the bottom one though, but these are. This does have reflective symmetry if I go right down the center, but it doesn't have rotational symmetry. The isosceles trapezoid, that has reflective symmetry. If I fold it across this line right here, it would work. Okay, so let's know how to mark up your shapes for the different figures. Primarily, we'll concentrate on triangles and quadrilaterals. There's other ones like regular pentagon, regular hexagon. But right now, for this kind of a topic, you want to focus in on your triangles and your quadrilaterals. So here's where we're going to use it. Typical one with like a Venn diagram. So we could have all kinds of different things. You know, this one has a right angle, represents this circle, has reflective symmetry. We could have something like has parallel sides, has adjacent sides that are congruent, has all the sides are congruent. You know, anything like that where it might be different kinds of combinations. So we're going to use this one, and then you'll have a label. Sometimes you'll have it with the figures. You could have it with names or even with both. So, first one, a right triangle. Well, right triangle has a right angle, but it does not have reflective symmetry, unless it was something like isosceles. So I'm going to put a letter A there. A kite does not have a right angle. It can, but it does not have to. So there's things that have to have it. So right here, it does, though, have reflective symmetry. We could fold it on itself, and it will lie on top of itself. A trapezoid, well, it doesn't have to have a right angle, and it doesn't have any kind of symmetry. So it is not anywhere in here. So we put that on the outside. So I'll put C on the outside. Now a rectangle, well, it has right angles, and I can fold it in half and have it lie on top of itself. So the rectangle would go in the middle. Equilateral triangle, well, all the angles on an equilateral triangle are all 60. So it doesn't have a right angle, but it does have reflective symmetry. Rhombus, again, does not necessarily have a right angle, but it is like a parallelogram, and all parallelograms will have reflective symmetry. So you have to kind of go through and you fill in the information. Mostly it's understanding and recognizing your different kinds of shapes and being able to know some of their properties.